Hey everyone, in this video I'll introduce a commonly used gas law known as Boyles Law. Now before we start looking at gas laws, it's helpful to review some of the different factors or variables that can affect gas pressure. So just remember that changing certain variables can increase or decrease the pressure of a gas. For example, if you increase the temperature of a gas, that change would also cause the pressure to increase because the particles move faster and collide with the inside walls of that container more often. Or if you increased the volume of the gas, that would have the opposite effect, decreasing the pressure, because in that larger space the particles will be colliding less. And fewer collisions, of course, results in less pressure. And these are helpful to look back at before gas laws, because you'll see that the gas laws are really just formalized statements of these different factors and how they affect pressure. So let's get started looking at some of our gas laws. Like I said, these are mathematical laws that summarize the relationships we observe between different variables like pressure, temperature, and volume. We use them as models that help us make predictions about what might happen when those variables change in real life, such as if the temperature increases by a certain amount, how much will the pressure increase as a result of that change. This video will cover just one of the gas laws known as Boyle's Law that was first published by this guy right here, Robert Boyle. So Boyle's Law is the first gas law, and it says that the pressure of a gas sample is inversely proportional to the volume of the gas while the temperature remains the same. So it's looking at two gas variables, pressure and volume. What exactly does that statement mean? Well, it's kind of just describing something we already know, one of our connections between volume and pressure, which says that if the volume is increased, the pressure will decrease because those particles are in a larger space and will collide less. That's an inverse relationship. The opposite is true as well if the volume were decreased. So if you squeezed or compressed those gas particles, that would cause the pressure to increase. Here's a nice little visual of that. The yellow area shows the gas sample. If the volume right here is decreased, and you watch the little pressure meter down below, here it is again, volume decrease, pressure goes up. You're also seeing this graphically. As the volume gets lower, the pressure gets higher. So that's kind of like the verbal statement of Boyle's Law. There is a mathematical side, an equation that goes along with this. The equation is P1 times V1, there's a little multiplication there, we don't always write it, equals P2 times V2. So let's talk about what this equation means and how you might use it. So the subscript 1s with P1 and V1 imply those are the initial pressure and the initial volume. So that's the pressure of the gas and the volume of the gas initially or before you make any kind of change. So before the volume changes, what's the pressure and what exactly is that volume? The subscript 2s on the other side of the equation, P2 and V2, those imply the final pressure and the final volume. Or once the volume and pressure have changed, what have they changed to? Or in other words, we're starting with this pressure and this volume, and we're ending with a new pressure and a new volume as these variables change. So that equation and that statement are the key ideas for this video. Make sure you've paused and taken a moment to write them down. That also concludes this introductory video on Boyle's Law. In the next video, we'll go over some examples of exactly how to use that equation. Thanks for watching, and here's a brief summary.